So, good morning to one and all. We have started the mutual inductance, and in that one mutual inductance, the concept of self and mutual inductance we have to discuss here now. In the electromagnetic induction, we have to discuss self and mutual inductance. In the yesterday class, we have discussed already what do you mean by self inductance, and this formula also we have discussed. So self-inductance is nothing but it is the property of material or virtue of it. It is a property of material or coil by virtue of which it opposes any change of current flowing through it. In a coil, current is flow, then flux will produces in that one. If the current is changed, then flux linkage will change, EMF will induces in that coil. For that reason, the inductance is nothing but it is a virtue of it opposes any change, whatever the flux linkage change होने वाला है ना, वो change होने वाला को oppose करते हैं. It's nothing but current changing. Current change it means then only flux linkage will change, so it will opposes the change of current here. No, so that is the definition of self inductance we are going to call here. No, so here the coil is there, this is the coil, here N is there, and the phi will be created here only. Surrounding here the flux will be created in the air only. Air core we have considered here, at the center of that one flux will be created here. This current is flowing in this conductor here. No, the current is flowing here. No, if the current will changes, whatever the flux linkage is there in that coil or number of turns N phi, it will changes. If the flux linkage will changes or flux will cut by a conductor, or conductor is cut by a flux, then EMF will induces in this coil. So that EMF induced EMF, if it is by changing the same current, it is the EMF is inducing here. Now same coil current changing in EMF will induces is nothing but that induced EMF is called self-induced EMF. We are going to consider. सेल्फ मीन्स दैट सेल्फ हियर नो, सेम वन कंडक्टर ओनली, ये सेम वायर यूज किए, यही कंडक्टर का करंट चेंज किए तो वो ईएमएफ इंड्यूस हो रहे. सो सेल्फ इंड्यूस्ड ईएमएफ, that is called we are going to consider here now. Self inductance is nothing but opposition of this change in current. Inductance means self induced EMF means the EMF induced in this coil because of changing the same coil current here now. So according to that, the self-induced EMF we are going to consider ES. ES equal to minus d by dt n phi. Since the flux linkage n phi is nothing but we are going to, it is related to what? When the flux linkage will change, because of n is constant, the phi is dependent on the current here. No, so the flux linkage is directly proportional to I. We can write down, because of this current changing, the flux linkage will change here. No, so I is directly proportional to n phi. Here I have written I is directly proportional to n phi here. Then es is directly proportional to minus d by dt n phi ka place mein we can write I here, we can write I symbol here. No, so here the remove the proportionality and take the equal and minus as it is, and the constant of proportionality I will consider, that is L. L is nothing but constant of proportionality. All self inductance coefficient also we are going to call that L here. No, so es equal to minus L di by dt would keep as it is here. No, where L is the constant of proportionality and is called as coefficient of self inductance. Self induction का coefficient है इसको, self inductance coefficient we are going to call, or self inductance also we can call that one. And its unit is, inductance का unit क्या है? What is the unit of inductance?
Henry.
Henry. We are going to call it. Yeah. Up to here it is clear?
Yes, sir.
Yes, sir.
The next part is here that we have to write the equation of the L, the self inductance का equation लिखना है. We know that, we know the formula of ES equal to minus d by dt n phi. एक फार्मूला मालूम है, इक्वेशन नंबर 1 प्रीवियस स्लाइड से. यस, इस स्लाइड से ये इक्वेशन मालूम है हमको. ओके, then second equation also ES equal to minus L di by dt also we know that one, that is second equation we are going to consider. Equation number 1 and equation number 2, the place of Ni we have considered here. No, so from this one here LHS is same only. Okay, no need to. So equating these two RHS of both here, no, d by dt both will get cancelled. We can write n phi equal to IL directly. n phi equal to IL लिख सकते.
Yes, sir.
So n phi equal to IL we have written here now. IL or LI both are same only. Both are same only. Here. Next we have to, we should know the formula for the self inductance कितना है बोल के identify करना है. So L equal to n phi divided by I. We can write the formula. L equal to n phi divided by I. So that is L here now. Self inductance equal to n phi by I here. If n phi equal to 1, if n phi is 1 Weber and I equal to 1 ampere, then obviously self inductance will become 1 Henry. So hence a coil has self inductance of 1 Henry of current of 1 ampere in the coil setup, a total flux of 1 Weber. 1 Henry self inductance है तो उसका flux linkage will be 1 Weber and current will be 1 ampere. It will plus set up the flux we are going to call that. So we have discussed two formulas. If the two formulas are equation number 1 and 2, we can write this one as equation number 1, this one as equation number 2. Equating these two, n phi equal to Li, we can write easily the formula of L here now. The problems will come. Determine the self inductance पूछा तो ये calculation करना है. Is it clear?
Yes, sir.
Yes, sir.
Will you take the notes? Dictation. Have you taken the heading of self inductance?
Yes, sir.
Yes,
Definition?
sir.
No, sir.
Okay, take the definition then. Take the definition. Take the definition. The property of coil. The property of coil. The property of coil. Property of coil. By virtue of which. By virtue of which. By virtue of which. By virtue of which. It opposes any change. It opposes any change. It opposes any change. It opposes any change in the amount of current flowing through it. Current flowing through it is called as its self-inductance. Is called as its self-inductance. Self-inductance. Full point, double inverted comma complete. Next line you write down. It is denoted by L. It is denoted by L. It is denoted by L and measured in Henry. It is denoted by L and measured in Henry. Henry. Henry के बाजू में ब्रैकेट में कैपिटल H लिखो. Capital H. Over.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, next line. Consider a coil of n turns. Consider a coil of n turns. Consider a coil of n turns carrying current I. Consider a coil of n turns carrying current I. Current I. Current I. Current I. Come on. Suppose full point दे दो. Current I. Full point. Suppose the magnetic flux linked with each turn of coil. The magnetic flux magnetic flux in bracket में phi लिखो, magnetic flux in bracket phi linked with each turn of coil, each turn of coil due to current is phi. Suppose the magnetic flux linked with each turn of the coil due to current is phi. Correct. Phi. Full point. Then flux linkage of the coil will be n phi. Flux linkage of the coil will be n phi. Full point. Next line is written. Full point. Next line. If current in the coil changes, if the current in the coil changes, then flux linkage in bracket you write on n phi. Flux linkage in bracket you write on n phi bracket close of coil will also change. Will also change and this change will set up a self-induced EMF. This change will set up a self-induced EMF. In bracket you write down yes. This yes in bracket में es लिखो. Set off a self-induced EMF in bracket es. In the coil, es हो गए, bracket हो गए. In the coil given by नीचे डायग्राम ले लो. ये the coil given by ये डायग्राम ले लो. उसके बाद जो ये एक साइड में डायग्राम ले लो, एक साइड में ये इक्वेशन लिख के इसको बॉक्स में लिखो. One side you take the diagram, another side you write the equation. Diagram first equation लिख के डायग्राम लिखो, नहीं तो डायग्राम लिख के इक्वेशन लिखो. These two you complete it. You write this one in the box and write this one as equation number 1. After completing that, you tell me.
Completed, sir.
Over.
Yes,
These
sir.
two
Yes,
over.
sir.
Okay. Next line you write down. Next line. Since flux is due to current in the coil, since flux is due to current in the coil, comma, comma, it follows that it follows that that flux linkage will be directly proportional to current. It follows that flux linkage will be directly proportional to the current. Directly proportional to the current. Now you write N phi is directly proportional to I. N phi is directly proportional to I. सिर्फ वो ये एक ही इक्वेशन लिखो. This one you write down. N phi is directly proportional to I. N phi is directly proportional to I. हो गया एक इक्वेशन, फर्स्ट इक्वेशन.
Yes, sir.
इसका नीचे देखो, differentiating above equation with respect to above equation with respect to t, we get you write this one, dn phi by dt and di by dt here. dn phi by dt proportional to di by dt. हो गया ना, dn phi by dt proportional to di by dt हो गए.
Yes, sir.
ओके, इधर dn phi by dt इक्वल टू माइनस es लिख सकते हैं हमने.
Yes, sir.
This minus I can send into RHS side. So you write here minus es is directly proportional to di by dt. Then minus es proportional to di by dt only, and therefore es equal to minus di by dt. ये दो बार लिखने का, इधर इसका बीच में ही लिखो, minus es is proportional to di by dt. Next line, this one, therefore es is proportional to minus di by dt. Es proportional to minus di by dt. ये इक्वेशन, एंड लास्ट वन लिखो, therefore es equal to minus l di by dt. इसको बॉक्स में लिखो, ये es equal to minus l di by dt. You write in the box and make this one as equation number 2. Over.
Yes, sir.
Okay, next line, where L is the constant of proportionality. Where L is the constant of proportionality, and is called as coefficient of self induction, or self inductance. Coefficient of self induction or self inductance. Full point. नेक्स्ट लाइन, नेक्स्ट हेडिंग ले लो, एक्सप्रेशन फॉर यल। ये अनदर एक्सप्रेशन बोल के मत लिखो, एक्सप्रेशन फॉर यल बोल के लिखो, सिर्फ एक्सप्रेशन फॉर यल बोल के अंडरलाइन करो, एक्सप्रेशन फॉर यल, एक्सप्रेशन फॉर यल। इसका नीचे लिखो, when a current through coil, when a current through a coil changes, when a current through a coil changes, an EMF is induced in it, an EMF is induced in it, full point. This induced EMF can be, expressed in following ways, following ways. Next line written, we know that you write both the equations, equation number 1 and 2. We know that this one and this one, equation number 1, equation number 2, you write down. Over?
No, sir.
Over?
Yes,
Only
sir.
ये दोनों
Yes,
इक्वेशन
sir.
लिखने का, 1 and 2, only you write the first two equation. After these two equation, you write equating equation 1 and 2, we get equating equation 1 and 2, we get n phi equal to Li. Equating equation 1 and 2, we get n phi equal to Li, and therefore L equal to n phi by I. You write this one in the box, and equation number 3 you write down, and up to here last you take down, up to the last you take it down. Over?
Yes,
Yes, sir.
Sir.
Some people you are writing in the chat box, don't write in the chat box. I will not I will not take the attendance from the chat box, remember. Okay. It completes the self inductance. Next heading, you take down mutual inductance. You take the heading mutual inductance and listen first. First, you have to listen. Okay. So the here in the previous self inductance, only one coil was there. By changing its current, the flux linkage was changing here. Means flux linkage of changing here, and in the same conductor, EMF was induced here. But here the mutual inductance, how it is happening here, I'll show you just a minute. I'll draw one diagram. What is roll number 15 now? Here I can write, I will consider this is one coil here now. Okay, इसके अंदर current flow हो रहा है अभी. I is flowing like this. Okay, I will take one more coil here like this. Okay, is it visible?
Yes, sir.
Okay, so mutual inductance means, see, this is one coil and this is second coil. This is number one. I will tell that one. This is number one and number two is there here. This is number two coil. See, once I will pass the current to this one, the current will flow here now, and the magnetic field will produce a surrounding to it like this. Yes, the magnetic field will be producers like this. Yes or no? So this
Yes, sir.
magnetic flux will link with this number of turns, that is N phi. If I change this current, the magnetic flux will change, and which is flux linkage will change. EMF will induce us in this coil, that is self-inductance. That is self-inductance. For the mutual inductance, I will increase the current. This flux will also link with this coil, which is nearer coil के साथ भी link है, the flux lines. Yes, ऐसा movement रहते ना flux line का,
Yes,
surrounding area of that one. So in this coil we have not given any supply and all thing here now. Here the conductors are there, the coil is there. Here, because of current flowing here, the flux linkage, the flux will produce us. That flux is linked with the second coil. The first coil flux is linked with the second coil. Here, because of this flux linkage and the conductor here, the current carrying conductor. If I change the current here, the flux linkage will changes here, and EMF will induce us in the second coil here now. So because of the first coil flux changes or first coil current changing, thus in the second coil EMF will induce us. That is nothing but mutual induced EMF. We are going to call that one mutual induced EMF. ये mutual induced EMF क्या करते? It will oppose us the change of current in the first coil. ये करंट कॉइल करंट चेंज हो गए तो फ्लक्स लिंकेज चेंज हो जाता है ना, उसके लिए फर्स्ट कॉइल का करंट चेंजिंग अपोजिशन करते हैं, दैट इज कॉल्ड म्यूचुअल इंडक्टेंस. वी आर गोइंग टू कॉल हियर. अदर कॉइल का चेंजिंग ऑफ करंट इट इज गोइंग टू अपोज हियर नो, सो दैट इज कॉल्ड म्यूचुअल इंडक्टेंस. द प्रॉपर्टी ऑफ टू कॉइल्स बाय वर्च्यू ऑफ व्हिच ईच अपोजेस, ये भी अपोज करते हैं, ये भी अपोज करते हैं, ईच अपोजेस एनी चेंज ऑफ करंट फ्लोइंग इन द अदर. एनी चेंज ऑफ करंट फ्लोइंग, सपोज इसमें किया हमने, सपोज इसमें करंट फ्लो कर रहे, इसमें ईएमएफ इंड्यूस हो जाएगा, इसके साथ सेल्फ भी हो जाएगा प्लस म्यूचुअल भी हो जाएगा. फॉर दैट रीजन वी आर डिस्कसिंग अबाउट म्यूचुअल इंडक्टेंस. मींस हियर द करंट इज फ्लोइंग, हियर ईएमएफ इंड्यूस्ड हियर. दिस ईएमएफ व्हाट इट विल डू, इट विल अपोज द चेंज ऑफ करंट इन अदर कॉइल का करंट चेंज अपोज करते. सो करंट अपोजेस any change of current flowing in the other is called as mutual inductance between two coils here. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
और कुछ डाउट है तो बोलो. अभी now only I will explain you. एक coil है, first coil, this is one coil, this is another coil here now. Because of this current flowing through this, we are supplying some current here now, so the flux will be created here and some flux will also link with the other coil here now. ये second coil के साथ link है, so EMF will induce self induced EMF हो गए. सपोज ये करंट मैंने चेंज कर देता हूँ, अभी पहला 5 एम्पियर्स था, बाद में 10 एम्पियर्स हो गए, then current change it means flux linkage will also changes, so it is also linked with second coil का कंडक्टर के साथ लिंक है, वो फ्लक्स लिंकेज चेंज हो जाएगा, चेंज होने के बाद ईएमएफ will induces here. So this induced EMF opposes the change of current in the other EMF. That is the definition of mutual inductance. Clear?
Yes,
Yes.
sir.
Okay. So next I will just a minute. Next I'll go for the next slide. This opposition occurs because changing current in one coil produces mutual induced EMF. Okay, I have already told that one. See here. Here they have explained in detail here now. So this is one coil. This is another coil here now. So the current flowing through the first coil is I1. The number of turns in the coil 2 is N1 and coil 2 is N2. Here there is no current flowing here now, but after induced EMF some current will flow here later. We will decide about that one. This flux is linked with this also. So whatever the flux phi1 is there here, that phi will link with phi 2 also. We are going to call that one flux linked with the coil 2 is phi 2. We are going to consider here. Flux linked with coil 2 is phi 2. We are going to consider here now. This flux is linking here. So the phi 2 is linked with both here, and this turns is N2. This one is N1. We are not discussing about self. Mutual means because of changing this current, the flux linkage means phi 2 and N2 will changes, phi 2 will changes and linkage will changes or not. N2 phi 2 will changes.
Yes,
Because
sir.
of this N2 phi 2 changes, EMF will induces in the second coil. For that EMF induced mutual inductance, we are going to call that one as EM. EMF mutual induced EMF is EM equal to minus D N2 phi 2 by dt. We have written here. The flux linkage is N2 phi 2 now. The flux linkage is N2 phi 2 here. EM equal to minus N2 d phi 2 by dt equal to minus d by dt N2 phi 2. We have written here. Soft here. This N2 phi 2, N2 how when it is changing? N2 is depending on this current I1. If the current I1 is changed, then N2 phi 2 will change here now. Flux linkage will changes. So yeah, I1 is directly proportional to N2 phi 2 here. So N2 phi 2 is directly proportional to I1. They have written here. I1 here now. So minus d dn2 of phi 2 by dt equal to em we have written. This is em, and minus, so in the place of n2 phi 2 we have written I1 here now. In the place of this n2 phi 2 we have written I1 here now. So em is so directly proportional to minus di1 by dt equal to minus m di1 by dt. So here where m is the constant of proportionality or mutual induction or inductance between two coils, you can call that. एक coil से another coil का दोनों mutual inductance का mutually of two coils we are going to call this one. This is the expression for the mutual induced EMF. Mutual induced EMF. Now our aim is to find the value of m. We have to find the value of m here now. Here one equation is there, here one equation is there. So equating this and this one, first and second we will equating that one here now. N2 phi 2 equal to m I1 we can write down. N2 phi 2 equal to m I1 we can write.
Yes, sir.
M
Yes.
N2 phi 2 equal to m I1 we can write here now. So em equal to m I1 equal to N2 phi 2, m equal to N2 phi 2 divided by I. This is the mutual inductance ka formula. Mutual inductance formula, that is. Is it clear now?
Yes, sir.
Okay, take the definition first. In the double inverted comma, you take the definition. The property of two coils by virtue of which each opposes any change of current, each opposes any change of current flowing current flowing in the other coil, current flowing in the other coil is called as mutual inductance between two coils, is called as mutual inductance between two coils, full point, double unit comma complete, it is denoted by m, right? M, it is denoted by m and measured in Henry. It is denoted by m and measured in Henry. Full point. Next line. This opposition occurs because a changing current in one coil, produces mutually induced EMF, in the other coil, which opposes change of current in the first coil, which opposes the change in is the screen is visible?
No, sir.
Okay, supply one. Now it's
Yes,
visible?
sir.
Yes, sir.
Up. No, इसको नहीं दिख रहा
Visible, sir.
visible, ठीक है, which opposes change of current in the first coil. Over. Up clear over.
Yes, sir.
Next line. You write down. Consider two coils. A and B. Consider two coils A and B of turns N1 and N2. Consider two coils A and B of turns N1 and N2 placed near each other, as shown in below figure. अभी ये डायग्राम ले लो तुम लोग. Now you take this diagram. आवाज आ रहा है ना?
Yes, sir.
Okay. ये डायग्राम ले लो फर्स्ट. As shown in below figure बोल के take this diagram. इधर भी dotted line है. This is the flux here. It is connected between two coils. Both two coils it is connected here now. Over. डायग्राम हो गए?
Yes.
Okay. Next line you write down. Next line diagram का नीचे लिखो. A current of I1 flowing through a coil A. A current of I1 flowing through coil A. Flowing through coil A. Flowing through coil A. Sets up magnetic flux phi 2, magnetic flux phi 2, magnetic flux phi 2, full point. This flux link with coil B, flux phi 2. This flux link with coil B. This flux link with coil B, full point. If the current in the coil A changes, if the current in the coil A changes, if the current in the coil A changes, then magnetic flux linkage of the coil B, the magnetic flux linkage of the coil B also changes. The magnetic flux
आवाज
linkage.
येत नाहीये प्रॉपर तुमचा, लॅग होतोय.
वॉइस आवाज लैग हो रहा है क्या?
हाँ यस सर.
ठीक है. वो इंटरनेट का इश्यू है थोड़ा, घर में ही अच्छा आता था, इधर कॉलेज में है मैंने. Then magnetic flux linking the coil B also changes. Full point. This will set up mutually induced EMF. This will set up mutually induced EMF. In bracket you write down EM. In bracket you write EM. Bracket close. In coil B is given by, you write this equation. Write that equation. Just a minute. You just write the equation, and after that one you write this next line also. Since the magnetic flux, इसको either EM बोल के लिखो, equation लिखो, और एक box में लिखो. This one you take equation number 1, and this one you take as a equation number 2. Next equation को equation number 2 लिखो. Up to the end of the slide you write down. Over.
No, sir.
No.
So along with patent, there is some other patent called as a design patent. What we have, like whatever we have, we can take the design and the life is about 14 years. Or non-obvious article design of articles or manufacturing.
Over.
Now is it audible?
Yes, sir.
Yes, sir.
Okay.
Then next comes
Next you write down small heading expression for mutual inductance.
trademark and service.
Expression for mutual inductance. Write the small heading expression for mutual inductance. The next line you write down. Now considering mutually induced EMF. Now considering mutually induced EMF in coil B. Now considering mutually induced EMF in coil B can be expressed in following ways. Can be expressed in following ways. Following ways. You write this one complete. All things up to the last here, up to इधर तक लिख दो. Complete it. You take up to last sentence here. Up to here you take down. Up to here you take down. See here, you underline this one. This is very important. M equal to N252 divided by I1. Because of changing the current I1 only, the flux linkages will change. That is the important thing. So mutual inductance we can calculate easily here by using this formula. Lastly, they have told that one N252 equal to 1 Weber. So number of turns will be constant and it will become 52 will become 1 Weber. We have considered turns ka unit nahi hai. N252 equal to 1 Weber and I1 equal to 1 ampere. Then M equal to 1 Henry. To produce the 1 Henry of mutual inductance, the current flowing through the coil should be 1 ampere and the flux produced will be 1 Weber. Here, that one only they have written here. Hence, mutual inductance between two coils is 1 Henry if current of 1 ampere flowing in one coil to set up total flux of 1 Weber in other coil here. Now, if they have written milliweber, you remove that milliweber. Over.
Yes, sir.
Yes, sir.
Okay, so it completes this inductance, Faraday's law of electromagnetism and all the things. So in the next class we'll discuss about single phase transformer. We'll discuss in that one and we'll stop here only now. We'll stop here only. Next class we'll continue in that one. So don't miss the next class. Remember, almost in 2 class your second unit will be get over. दूसरा I think